All right, this is a review for our quiz in Unit 5. Unit 5 is Systems of Equations. So this is just a quiz review, and we remind you that when you have a system of equations, you'll have two different equations that are put together using that open-ended curly brace. It lets you know that there's a system. They are related in some way. And if you have a system of equations, you are trying to find the x and y, the ordered pair that works for both of those equations. So we have three different ways of solving for the ordered pair that is the solution, or sometimes we find that there is no solution, and sometimes we find that there's an infinite number of solutions. We can solve by graphing, or we can solve by substitution, or we can solve by elimination. And so you can generally choose which way you'd like to solve, although for your quiz we will ask you to solve using a specific method. If you are more comfortable with one method than another, just use your more comfortable method to check your work. All right, so we're going to look at our first problem here, and this is an error analysis problem. So what it means is something is wrong with the answer. Okay, so Joey attempted to graph the following system. We are graphing y equals 2/3 x, and we are graphing 2x plus y equals -4. So remember, when we're graphing, we're going to graph each equation, and it's often easy to just graph using the y equals mx plus b format. Okay, so that you'll start by graphing your b or y intercept, and then you'll use the slope to find the next point. So I'm going to use that method, and I'm going to, on my own, I'm going to graph these same two lines, and just make sure that Joey didn't accidentally graph the lines wrong. Okay, so y equals mx plus b, that means my m here in the first equation is 2/3. So rise over run, it means I go up 2/3. And my y-intercept is 0, right? Because there is no y-intercept there. All right, so if I wanted to plot this first line, I would start at 0, and I'd go up 1, 2, and over 1, 2, 3. Up 1, 2, over 1, 2, 3. So it looks like that first line is graphed just fine. So now I want to graph my second line, and for my second line, I want it to be y equals mx plus b format also. So this is my second line, right? I need to rearrange that line. So I'm going to subtract 2x from each side. So I'll have y equals -2x minus 4. How about I make that so you can actually read it? Y equals -2x minus 4. So now I know for my second line, m equals -2, or I'm going to go down 2 over 1, and I know b equals -4. For my second line, I'm going to try to mark it on the graph with my yellow. I start at -4, and I'm going to go down 2 over 1, right? So down 1, 2 over 1, and then I'm going to back myself backwards. 2 backwards. And so, oops, I can see already that Joey accidentally used the wrong line when he graphed, he or she, because Joey could be he or she, right? So when they graphed the second equation. So this is not the correct answer. I know it's not the correct answer because if I were to plug in x equals 3 and y equals 2 in this first one, 2 equals 2/3 times 3, that's true, right? So my first equation does work with that ordered pair. But my second equation, if I plug in x equals 3 and y equals 2, you see this does not work, right? Because 8 does not equal -4. And so you know already that those ordered pairs, the ordered pair doesn't work for both of those equations. The issue is that Joey accidentally graphed that second line incorrectly. Okay, so if we look at the back side of our quiz review page, this next problem asks us to solve that system using substitution. So you can get a reminder on the front side if you want to. On the front side it says with substitution, the way you start is you are going to rearrange if you have to, but you want to get one of the equations, you want to get one of the variables isolated all by itself so that you can substitute in the information. So here I have 3y equals x plus 10, and I have 3x plus 2y equals 14. I'm going to rearrange the upper equation so that x is all alone. So I'm just going to subtract 10 from each side. 3y minus 10 equals x. Now I know all of that equals x, so I'm going to plug it in to the next equation that I haven't used yet. So 3x, instead of 3x, I'm going to say 3 times 3y minus 10 plus 2y equals 14. So 3x, instead of 3 times x, I know x also equals all that, so I'm just substituting that in. And then I'm going to use distributive properties, so I have 9y minus 30 plus 2y equals 14. And so I have 11y minus 30 equals 14. 11y equals, I'm going to add 30 to each side, so I have 44, and y equals 4. Once I find the information for one of the variables, I'm just going to plug it right back into the original equations. I can pick either one. I'm going to go ahead and do the top one. So I have 3 times 4 equals x plus 10, 12 equals x plus 10, 2 equals x. So I now have my x and my y, so that's my ordered pair, my x and my y, and that would be my answer there. Okay, and forgive me, I just noticed I just completely ignored other problems on our front page. I don't know why. So here's our front page, Unit 5, Day 2. This is our quiz review. So sorry, I didn't mean to ignore these. We have 2 more questions down at the bottom. We're going to solve these systems equations using each of the methods that's specified. So if I want to solve using elimination, I want to make sure everything's lined up, and then I'm going to try to eliminate one of the variables. Okay, and so I look at my coefficients, 2x plus 3y equals 6, I have 2x. On the next problem, I have negative 4x minus 6y equals negative 12. So I'm looking at these coefficients, everything's lined up properly, but I don't have any opposites. So I need to fix that. Remember, you can multiply or divide when you're trying to rearrange your equations. So I'm going to actually divide the whole bottom equation by negative 2. Nope, I'm sorry. I'm just going to divide it by 2. The reason I'm going to do that is that's going to give me an opposite. I will have 2x still in my first equation, but if I divide by negative, sorry, I can't get this right. If I divide it by positive 2, I'm going to be left with negative 2x. Okay, so my first equation, I'm just going to carry it over. It's still going to be 2x plus 3y equals 6. But my second equation, I'm dividing every term by 2, so it's going to be negative 2x minus 3y equals negative 6. And then I'm going to add them together. Okay, 2x minus 2x is 0. 3 minus 3y is 0. So I have 0 on my left. 6 minus 6 is 0. I have 0 on my right. That is always true. So these must be exactly the same line. And so I know that my solution is all real numbers. Every x and y ordered pair that works for one equation will work for the other. All right, over here I'm still also using elimination to solve here, but I notice that even though I have x in the right place here, my equal signs are not aligned and my other terms are not aligned. So I'm going to rewrite. I'm going to say that this is 4x minus 7y equals 2. I just subtracted 7y from each side. I'm just going to completely move this same exact equation like it is over so that I'm lined up. Okay, now I don't have any opposites. So I'm going to have to manipulate these equations so that I can eliminate one variable or the other. And I don't see anything super easy and obvious. So I'm going to, it's kind of like finding a common denominator. So I'm going to multiply my upper equation by 3. I'm going to multiply that all times 3, so I'm going to have 12x here. And I'm going to multiply my lower equation by negative 4, because then I'm going to have negative 12x there. So what this does to me is I have 12x minus 21y equals 6. And on my bottom equation, I have negative 12x plus 12y equals negative 24. Now I can see that I have an opposite coefficient. So 12 minus 12 is 0, so I have 0 x's. Negative 21y and 12y is going to give me negative 9y, and that equals negative 18. divide each side by -9, and I get y equals 2. So I have found y, and I'm going to plug that into one of these equations to find x. So I'm going to plug in y equals 2. I have 4x equals 2 plus 7 times 2. 4x equals 2 plus 14. 4x equals 16, and x equals 4. I have my x, I have my y. My ordered pair is 4, 2. Okay, back to your regularly scheduled program. Now you can look at number 4 if you didn't look at it before, and then we're going to take a look at number 5 and practice solving with elimination again. Elimination or substitution. I'm given the option, solve the system using substitution or elimination. So substitution is a fine option because I can get this y all by itself. So first I'll solve it with substitution actually. So this whole equation, I'm going to make y equal 5x plus 7. I just added 5x to each side. And so I will plug that in any place I see y in the next problem. 8x minus 3 times 5x plus 7 equals -21. 8x minus 15x minus 21 equals -21. And so I have -7x minus 21 equals -21. -7x equals 0, x equals 0. If x equals 0 and I plug that in, then y must equal 7. So my ordered pair is 0, 7. If I had wanted to solve that by elimination, I want to make sure everything is lined up properly. And I can see that if I change my y here, if I make it positive 3y, it'll eliminate. So I'm going to multiply my upper. I'm just doing a whole different method here. If I multiply my upper equation by 3, I'm going to get -15x plus 3y equals, multiply by positive 3, so 21. Okay, so this is elimination method. Okay, so I'm going to carry down my old equation, 8x minus 3y equals -21. When I add them together, I get -7x equals 0, and again, x equals 0, and I'll still get 0, 7. Okay, so two different methods. This one was the substitution method up here. All right, and finally, the last two we're going to solve by graphing. My preference for me personally is to rearrange into y equals mx plus b format, but you do not have to do it that way. That is how I'm going to do it. So that gives me y equals -3x plus 5. So I start at 1, 2, 3, 4, 5, and it's a negative slope, so I'm going to come down 3 over 1, and so on. So that's that. And then my other equation, I'm going to rearrange. So I have -4y equals -x plus 32. And I have y equals 1/4 x minus 8. So I start at -8. And I go up 1 over 1, 2, 3, 4. So that point right there, oh my goodness, I'm so sorry. I started at -8 and I went up 1 over 4. This point right here, if I had drawn a straighter line, you would see that that's exactly the point I want. I go up 1 over 1, 2, 3, 4. Okay, and so this ordered pair is at 1, 2, 3, 4, and -1, 2, 3, 4, 5, 6, 7. So 4, -7 is my answer. Can you see that? 4, -7. And I can plug those two ordered pairs back in just to confirm that I've gotten that right. Okay, over here we're going to solve by graphing again. This is already in slope-intercept form. So I'm going to start at 4, 1, 2, 3, 4, and I go up 1 over 1. So that's my line. And I'll try to make a straighter line that time. Okay, my second equation, I need to rearrange. So I'll subtract x from each side. So I have -y equals -x plus 1. And then I make that y equals x minus 1. So I start at -1. I go up 1 over 1, and I know already that I have the same exact slope with different y-intercepts. So what that means is that my two lines are parallel and they will never meet, so there is no solution. No solution there. Okay, good luck when you get ready for your quiz.